Okay, so moving on with part 3, this is the second part here where we're going to take part 3's implementation plan and go ahead and code it out. So let's go ahead and get a player set up, at least a temp player, just an actor really with a player texture, and get the flicker, the drawing, the scaling, all that stuff in place. So Logan, let's go ahead and jump over into Visual Studio Express.
All right, this is where we had left off in the game class.
And following along with our implementation plan, first thing we said is let's go ahead and add in a player texture field in the game class.
All right, so for that I'm going to jump all the way back up to the top and jump in right after I define the background texture. As a matter of fact, I'm going to make a copy of that and change this to player texture.
Okay.
So that will take care of our, let me get the spelling on texture. And the casing on texture. So this gives us our player texture field.
Okay. And now let's go ahead and jump down to the load graphics content and create an actor.
And before I do that, let me load in the texture as well. So
okay.
we load in player texture, and we populate that with this player texture asset. So we load in player, and then we can turn around and create a new actor.
Okay.
Now the interesting thing here is I'm not going to define a variable to hold it. All I'm going to say is new actor. And then of course I'm going to need to give it a texture, which I will give player texture, and that's it.
That's right. Well, we know by creating a new actor what happens when the constructor gets called. Let's go and jump back over to actor real quick. So here we are in actor, and on the constructor it gets added into the list, so now we have a means of walking through that list as we've already mentioned in update and all. So good to go. Okay, so now that we've got that in place, let's go ahead and start hooking some stuff up inside of actor. Like let's go ahead and address the constructor for getting the texture assigned. Ooh, the texture is assigned. How convenient. We actually did a little bit of coding in the skeletoning lesson. So we need to get the tint set up.
All right. I need to initialize the tint to some useful color, because if we leave it here, we see we have a field but no initialization for it.
Right.
The problem is if we have all of its components, including the alpha component, defaulting to 0, then we have a texture that defaults to being transparent. So we want to come up with some texture that will leave the texture or the actual texture at its default color. So for that, I'm going to initialize it to this.tint equals color.white. So unless some tint is specified, more commonly by the cells in action,
okay,
then that'll leave it set to white.
All right, very good. So now let's go ahead and get draw actors and draw set up.
All right, so let's move down to, I'm going to hit draw first.
Okay.
So we'll build up from here. Draw is going to need to make the call to spritebatch.draw and feed in the necessary parameters. So let's start some of that. We know we have a sprite batch coming in as the parameter. We're going to be drawing. And the first thing we need to specify for draw is a texture. Before I do that, let me jump down in the overloads, because I want an overload that allows positioning as a vector 2 and allows for things like origin.
And scale.
Alright, so starting off we have a texture held as this.texture. We have a position held in this.position. We do not have a source rectangle because we're not going to use any type of source drawing from a sprite sheet. So I'm going to null out that rectangle. The color is going to be provided by this.tint. The rotation is going to be 0, so I'll plug in 0f. The origin should be given by the origin property, or this.origin. The scale for now will be hard-coded to 1. The sprite effects will be set to none, and the layer depth will be set to 0. And that finishes off the call to draw.
Okay, very good. So now we can go ahead and shift our attention over to draw actors.
Alright, instead of draw actors, we need to go through the list and call draw for each individual actor. So for this, I'm going to set up a for loop. So there's 4. I'm going to grab the template to grab I as an index variable, and then I'm going to jump over to length. The length that I'm looking for is found in actors.count. So we'll go through each individual actor. Now I need to call upon the actors individually and call draw. So we can use that by looking at the list, saying actors sub I dot draw, and then pass along the sprite batch. And that will accomplish what we need for draw actors.
Okay, so that takes care of the constructor, draw, and draw actors. So now it is time to shift our focus to Flickr. So
before we do that,
you want to actually see if...
Yeah, let me set it up in game, because I think if everything's in place, because remember, down in draw, we're making a call to draw actors right here. So in theory, it should work. So
and because of the origin, it should actually be offset in the upper left-hand corner of the screen because everything's at 0, 0.
So let's test that.
And hey, there it is.
So check it out. It is centered upon 0, 0, so only 1/4 of it is showing.
So let's see if we can position it somewhere.
All right. This will go back to the access method through that list, because remember, there's no reference here yet. Of course, there is really a reference if we look into actor. Actor has the actors list. Actors list, we know we're going to have an element because we've just made an actor, so I could give it sub-0, and there we have all of the properties we need. We could give something like position and set a position. So I'm going to give a new vector2 of 200 by 200, and in doing that, we have now moved the actor closer to the center of the screen.
Hey, nice. Okay, so now that we've tested out all of our new code and we see that all of it is working right, now let's go ahead and shift our attention over to Flickr.
All right, so moving into Flickr. Let me scroll up to the section where we have fields, and let me set a comment down for Flickr to denote these as flickering fields.
Okay, so let's go ahead and start out with our constant, which is a float Flickr frequency.
All right, so constant float, this will be Flickr frequency.
And I believe we're going to actually initialize this to 15. Well, not initialize, it's a constant. We're going to set it to 15.
Right, just some values we had played with somewhere between 10 to 15. I think 15 looks good.
So let's go ahead and set up some private fields now that we can use for things like visible, flickering.
Okay, so both of these will be booleans. So we've got a bool for visible, visibly. So visible, and then a private bool for flicker.
Okay.
And then one last field, this is going to be the double for next Flickr update. Alright.
Alright, so now that we have that in place, what did we need to do to actually make it draw? Well, we could, let's go ahead and set up the Flickr property. I was getting ready to jump down into some meat, but we'll do that in just a second. Let's go ahead and set up the properties for it.
Let me expand the properties region and jump all the way to the bottom. So right after radius, let's jump in and add some properties.
And if everybody recalls, in the last video I said that inside the Flickr property we were actually going to do something interesting that will make sure that when we set Flickr off, we always have a guarantee that we'll always have our guy visible.
Right, always want it to come back after flickering stops. So to begin with this property, it's going to be a public boolean called flicker, and I'm going to make this property write only. If you should need to read it, then you can just add a get accessor. In our code, we're not going to use that, so I'm going to give only a set accessor. Inside of that set accessor, we'll do the first and obvious thing, and that is to set this dot flicker equal to the given value. That makes sense. But here's what we have to consider. Since flicker is kind of like the on-off switch for the flickering system, meaning if flicker is set to true, it's like turning flickering on. If flicker is set to false, it's like turning flickering off.
Right.
Now here's the thing though. Flickering could be turned off at any moment. And for half of the time, the flickering object is going to be invisible. Visible is going to be false. So what would happen if we stopped flickering while visible is false? Well, in that case, we would leave the actor invisible, so it would just disappear. We want to make sure that we prevent that, so that no matter what happens, whenever we turn flicker off, we want to turn visible on. And I can do that by just inverting the value. That would be saying this dot visible is equal to not value. Because what's value going to be? The new value for flicker. What if flicker is set to false? Then we want the visible to be not false, or true. Now this does have one other side effect, which I almost consider beneficial, and that is the moment you turn flicker on, the actor in question immediately goes invisible.
Right.
But I would consider that the first flip of the actual flicker process that begins. So that way you see an immediate effect in that the actor immediately goes invisible.
Right.
But of course, it's the greatest thing gained here is that visible will always come back on when flicker is turned off.
Okay.
Alright, that takes care of the flicker, and I believe that was it for the property. It was just one property for
it is. So we can go ahead and jump down to draw real quick because it's very easy to implement flicker into draw, which is basically we're just going to look and see what the state of visible is.
Right, because that's the idea of visible, is to make a very simple on-off switch. So if visible, let me change that to this dot visible to denote the field, then we draw. So if visible, we draw. If not visible, we don't draw.
Right.
It's as simple as that.
Okay. And now all we need to do is take into account flicker inside of update.
All right. So here we need to do the first check in update is, are we supposed to be flickering right now? And that is check from the flicker field. So if this dot flicker is true, then we should be flickering. So we need to look at timings and decide if we need to flip the visible field. So first thing we need to do is do a check based on time to see if enough time has passed. We're now past the next flicker update. So that check is done is if game time dot total game time dot total seconds is greater than next flicker update. If that's the case, then we've passed that new time interval and we need to perform the actual flicker. And like you said, that means we need to toggle visible. So that means this dot visible equals not this dot visible. And the value will toggle. Now, since we've toggled the value, we need to set a new time in the future so that we wait another amount of time before the situation happens again. And we can do that by setting the next flicker update field. We'll set that to the current time, which I'm going to get lazy and copy here just so I don't have to type it all out. But what is the current time? It's still game.totaltime.totalseconds. That is the time right now. But we're looking for a value in the future, so we need to add on to it some value. Now remember that frequency, as we talked about on the whiteboard, frequency doesn't represent an amount of time, it represents a number of time slices per second.
Right.
So we need to invert that. We need to get the reciprocal to convert that into an actual time in seconds value. Since we're dealing with seconds, I'm going to take this over 1, or 1 over the frequency. And as was drawn on the whiteboard, we've shown that that will give the correct amount of time in seconds to advance into the future.
Exactly.
So with that, now we'll have this advanced, and we'll be looking for that in each additional update as long as flicker is left on.
Fantastic. Okay, so with that, we can go ahead and set this up and test it out.
All right. Let me do a quick build and make sure I haven't induced any errors, but everything looks fine. Build succeeded. All right, now over to game where we can test this. Testing should be as simple as taking this actor and turning flicker on.
Right.
So we'll grab actor, dot actors, 0, dot flicker, and set that to true. And before I even do that, let me make sure that the code doesn't break anything. I'm going to comment that line out and run to make sure that we still have the actor as we remember. And look at that, we don't.
He's invisible.
Why would that be? Well, let's take a look at what visible might be. Well, visible is unset, so it's going to default. It's a Boolean, so it's going to default to false. It's false, it's obviously not going to draw. So it would be a good idea to initialize visible to true. And in doing that, if we don't mess around with flicker, then we have visible actors, which is desirable. Now we can go in, now that we've proven that we haven't broken anything, let's turn flicker on and test the flickering code.
I see flicker.
What do you know? So we've got a flicker effect in place.
Let's go ahead and test the frequency. Let's go ahead and set it up to 1 so that we just see 1 flicker every second.
Okay. So setting the flicker frequency to 1 should result in a second of the actor being on and then off. So 1 second per change.
And then if we change it to 2, it should be twice as fast.
So now upping the frequency to 2 results in twice as fast.
Very nice.
And we can set that all the way back up to 15, and that gives our desired flicker effect.
Outstanding. Okay, so flicker works, and that is out of the way. So the next thing we're going to do is go ahead and shift our attention over to the animated scale, which means we've got some fields to put in according to our implementation plan.
All right, so still in actor, let me jump below the flicker fields and add in one more comment to denote scaling fields.
Okay.
So our scaling fields, we're of course going to have our scale, scale time, and scale per second. All of these are going to be private, and they're all going to be floats. So the first is private float for scale, another private float for scale time, and finally a private float for scale per second. And that takes care of fields.
Okay, so now we've got a couple of properties that we need to go and get set up.
All right, let me jump back in and expand the properties region. Jump all the way to the bottom. There we go, there's flicker. All right, right below flicker, we want to put in 2 properties. We want to put in a scale
and is scaling. Yeah.
So first is going to be a public float, which acts as an accessor to the scale field. So we'll call this scale, and inside of it we'll have a get and set accessor. The get will, of course, simply return this dot scale, and the set accessor will set this dot scale to the given value.
And then we'll go ahead and set up our is scaling, and again it's going to return a bool, and it's going to be just a very simple expression that's just going to compare scale time to 0.
All right. This is once again going to be public. It will be a boolean, and we're calling this is scaling. Is scaling is going to have a get accessor that returns whether or not scale time has any time left in it, or rather if this dot scale time is greater than 0. And that takes care of the properties.
Okay. So the next thing we wanted to do is go ahead and create that new start scale method.
All right, so let's jump down. This is a
excuse me.
New method to add in. And this is what we were talking about with the skeletoning section, and that we're not yet where we hadn't skeletoned in the scale because we didn't want to have that muddy the idea of what actor was doing in a basic sense.
Right.
Now we've moved on past that, and it's time to add in this method in order to handle the set scale. So this method is going to be public. It has no return, so we'll set it to void, and it is called start scale. Now, start scale is going to need to take in two things, two floats, a target scale and a scale time. So our first float is that target scale, and our second float is the scale time. Alright, first thing we need to do in here, as we had talked about, is make sure that we can't invoke scaling over itself, meaning if we're already scaling, simply return and ignore any additional calls to start scale until the scaling is done. That means a check of if this dot is scaling, so if we are currently scaling inside of this call, simply return, because there's some scaling operation already in progress, so we'll ignore the subsequent calls to start scale. Alright, next we need to take a look at time, and that is to simply set the scale time field. So we have a scale time, a desired time for the scale to take place coming in, so we'll set this dot scale time with that parameter. And now on to the formula for calculating scale per second. We know the field that we're setting is this.scale per second, and now we need to implement that formula that was discussed on the whiteboard, and that is taking the target scale and the current scale to get an overall desired amount, and then dividing that by time so that we have the scale in per second. So that is in the formula of target scale, again, there's target scale, minus our current scale, which is represented with this dot scale. So that gives an amount that we need to scale, and then we can divide that by scale time so that we end up with the amount of scale per second.
Excellent. All right, so with that guy out of the way, it's time to go ahead and turn our attention over to update, so that inside of update we can go ahead and have the item scaling.
All right, let me scroll back up to update. And the first thing to do in update is to check if we are currently scaling.
Right.
So I'm once again going to check that property, this dot is scaling, because if a scale is in progress, we need to have update increment the amount of scale as well as decrement the scale time.
Exactly.
So beginning with the scale, this dot scale needs to be incremented by whatever the scale per second value is, but then of course scale per second has to take in an amount of time. So that means we'll increment by this dot scale per second multiplied by the elapsed game time. Now, of course, elapsed game time in total seconds is going to be a double, so right off the bat, I know I need to cast that to a float to calculate it against scale per second. Or, increment it into scale.
Right.
But what we're looking at here is game time dot elapsed game time. Because remember, in the past in Flickr, we were using total game time because we were looking for times into the future. Here we're looking for how much time has gone by since the last update, and that is given in elapsed game time. And then we would like that elapsed game time to be presented in total seconds. So that's the amount of time that has passed since the last draw. So that's what gives us that very low 0.0167 value. So if we had some, like half a second, we'll decrement that way down so that we actually do that over 60 frames a second, or whatever we happen to be updating by. But anyway, moving on now, we need to decrement the scale time. That is, this dot scale time needs to be decremented by however much time has passed. And for that, I'm going to steal the rest of this line, because we've just discussed that is the amount of time that has passed, and that's the amount of time that we need to take away from scale time.
Right. Now we need to make sure that scale is being initialized to a value of 1 so that nothing disappears.
Because we already had that fun with the actors visible.
Exactly.
So let's initialize this.scale to a value of 1. So that way if scaling is, say, ignored in a non-scaling actor, it will simply default to the correct value.
Right. And then finally, down in draw, we need to make sure we use scale to scale the sprite.
So over here, I'm going to invoke IntelliSense, and we can see that this is where I'd hard-coded scale to 1. So I'm going to replace that with this.scale.
Yes. So now we can test it out, make sure everything builds. There we go. Now, let's test some stuff.
All right, I'm going to comment out the flicker line, and then let's bring that actor back up, actors 0, and now let's start a scale. Let's scale to a target scale of maybe 3, and let's do that over maybe 2 seconds. So when the game starts, we should have a scale of 1, because that's what we initialized to in
That's
actor.
right.
Then we should scale up to a value of 3 over 2 seconds. So let's see if this works.
Hey!
Oh, it does indeed work.
Very nice.
Now, to make this a little bit more fun, let me take this and put in a little bit of update code so we can have a button on the gamepad updated. This is just temporary code, but just because it's nice to test, and it will also allow us to test both scale up and scale down. So what I'm going to do here is steal these 2 lines, since I know those get updated for a given button. Then I'm going to change that button to A, and then for the A button, I want to start a scale. So that means taking that actor, and I'm feeling incredibly lazy, so I'll copy that entire thing. For some reason, I didn't feel like typing that again. So actor 0, once again, we'll do a start scale. Now this time I want to do something interesting. Instead of giving a specific amount in units, let's give a percentage of its current scale. To get a percentage, we need to know what it is now, but if you remember, the property also has a getAccessor. That means we could do something like that actor, which I could probably just paste. I believe it's still on the clipboard. Dot scale, given as a property, and let's have the A button scale the actor up. So let's multiply it by 2, so it doubles in scale every time we press the A button. And then let's have that scale take place over the time of 1 second. And then let me take that whole thing, copy it again, so that I can code in something for the B button, where the B button does the same thing except divides by 2, so we get a half of the scale. And if that builds, we should be able to run. Now if I press the A button on the controller, the actor grows, and continues to grow, and continues to grow.
And you can check the double clicking too.
So scaling down now, if I press, let's press the B button over and over again. And while we do happen to catch that right after it's done scaling, we don't mess anything up by causing a lot of scales to happen over each other.
Exactly.
Because if one scale is already in progress, all subsequent scales are ignored until scaling is done. So now I can scale down, and then shrink way down to almost nothing.
Beautiful. Logan, my friend, this is what we have set out to accomplish for Part 3, and we have followed the implementation plan presented in the last video to the letter. So yeah, anything else?
Nothing comes to mind, but that does prove that the 2 effects that we need, flickering and scaling, are in place and working.
And we can draw actors.
So to wrap this up, I'm going to wipe out these 2 lines because we need those buttons to do real things here in a little while in the actual game.
Okay, and so with that, that is going to conclude this video. Thanks a lot.